Hello again. In our last video, we were looking at defining a Boolean expression called left is dark that would determine if the square to the left of the robot was dark. And we did what you might consider the obvious thing. Well, you may not have chosen to slide left, you might have turned left and moved. Either way, is certainly fine. But I decided my robot is going to slide to the left and remain facing its original direction. And that's what the slide left method does. In other words, it turns left, moves, and turns right. Okay, so that's slide left. My left is dark, slides left, tests if the robot is on dark. If the robot is on a dark square, it now returns true, and otherwise it returns false. And the surprising thing is that when we run that method, so when I call this method as an expression, and I evaluate it to see what Java's response is, and I get back false, which is good because there was no dark square to the left of where the robot started. What's disappointing to me is that the robot is not where it was before. That seems very surprising, that when I ask a question, that not only do I get an answer, but there's a side effect that changes the state of my robot world. So I wrote here that afterwards I don't want a side effect, that although there may be times where I want to define methods that return a value and have a side effect, for a while we're going to try to keep these ideas separate. We're going to make sure that our methods either have a side effect and return nothing, and therefore we write void, or they don't have a side effect but they return a useful answer to us. And so this method, since it returns an answer that we want, we're going to make sure the method does not have a side effect. How are we going to do that? Well, the side effect is that the robot is in a different position. So if we want to eliminate the side effect, we need the robot to be back where it started. Now, we can't get rid of, this is a trick, by the way, of commenting out a line of code to make it not compile and not be part of our program. If I get rid of this slide left method call, then all I have is if it's dark, return true, and otherwise return false, which means I'm just testing if the original square is dark, not if the square to the left is dark. So that's unacceptable. I definitely need my robot to move onto the square to the left. What else could I do? Well, I could try sliding right at the end. Let's try sliding back right at the end. So that's in my swap file. That's the file I'm working in now. Slide right at the end. That sounds good, right? Let's give that a try. So I'm hitting F5 to compile now. And uh-oh, 2 errors found. What's my error? Unreachable statement. And that statement that's unreachable is the one that's lit up right now, my slide right. Why is it unreachable? What does that mean? We're going to see that error message a lot. This line of code is apparently unreachable. Well, here's why. When I told you about the return statement, I didn't tell you everything you need to know about the return statement. So let's go back to the drawing board. The return statement. So the return statement will, let's describe what the return statement does. It will evaluate the Boolean expression and return that value as the value of the method call, original method call. But return is an active thing. So for example, imagine, let's put it this way. So return means returns immediately from the method. And what does it return? It returns that value as the value of the original method call. Not sure that's correct English anymore, but I think you get the idea. This statement is going to return immediately from the method. That means it's not going to execute any further instructions after the return statement. It doesn't. The program doesn't continue. It stops. So the method, maybe we could write it that way. Evaluate the Boolean expression stops the method, right? Ends the method, and then returns. So we're not going to be able to, let's go back to our program over here. We're not going to be able to slide right after we've returned. In either possibility, whether we were on dark or not, we already returned. So not only did Java note that the return value should be true, it returned. It actively left this method, and so there's no way we could reach this line, because if we reached this line or this line, and we had to reach one of these two, then we've already returned. We've already quit the method. It doesn't matter what else was here. So return means return immediately. It's as if your teacher said, class dismissed, and here's what the homework is for tomorrow. Well, probably everyone already sprinted out the door when your teacher said class dismissed, and therefore no one heard what the homework was. So same thing here. Java already sprinted out of this left is dark method when we said return true and return false, and didn't stick around to slide right. And it knows this is going to happen, so when I hit compile, it tells me this statement is unreachable. There's no scenario where this statement will execute. Well, that's a problem. We're going to see this error message many times, by the way, going forward, so file that away. Unreachable statement means you've already returned, and you tried to execute code after that, and it usually means you've forgotten that return literally does return from the method and end the method right there, immediately. Okay, so we can't slide right after the return. So maybe we can slide right before the if. Let's try that. Compile. I'll load my little world here. Where'd it go? There it is. And we will test if left is dark. Oh, that's the correct answer. Good. Let's try another scenario. What if we make the current cell dark and test if the left is dark? Ah, now I get true. No, but the left isn't dark. The left is light, so this is disappointing that I get back true. Why do I get back true? Because this program says first go to the left, then go back to the right. That means the robot is now back on its original square. And then we say test if the robot's on dark. Well, that means we're testing the original square. So it's critical that we don't slide back to the right until after we've tested if we're on dark. But we have to slide back to the right before the return. So the sliding back right must be between testing if we're on dark and returning. So how about here? Compile. Load my world. Test if the left is dark. False. Oh, but it didn't return. Why didn't it slide back to the right? Ah, because when I return false, I don't slide back to the right. So unfortunately, that means I need to slide to the left, test if I'm on dark, then either way, slide back to the right, and then return the appropriate value. So it's like simply because the thread of execution has entered this block, it's going to remember to return true. And if the thread of execution enters this block, it's going to eventually return false, even though we start by doing the same thing. I think this leads to an important observation. Maybe I should confirm that this works, but trust me, we actually have it correct now. Slide to the left, test if you're on dark. If so, slide back to the right and return true. Otherwise, slide back to the right and return false. That's how we eliminated our side effect. So now when I ask if the left is dark, the robot will remain in its original position after doing a little walking around. Here's what I want to observe about this code, though. What did I want to observe about this code? We've seen that sometimes we can simplify an if both branches of the if do the same thing. And so here's a moment we realize, hey, we're sliding right at the beginning of both branches of the if. Doesn't that mean we can pull slide right out of the two branches of the if and do that before the if? And the answer is no, because by sliding right before the if, I will change what square I'm on and therefore change what square I'll be testing if it's dark. So I really do need slide right in both parts here. That makes me think there might be a better way, because I don't like writing something twice. And there will be a better way, but we're going to have to wait until we get to variables to see how to do this implement this method a little cleaner. Alright, I think that ends any new material I'm going to teach you in this particular video, but I thought maybe we'll just run it and convince ourselves we really did succeed. And then in the next video, we'll actually, let's bring that up, in the next video we'll actually put all of these ideas to use and solve this original problem of swapping the pattern on the left side with the pattern on the right. So now if we say swap is my file name, left is dark, I should get back false. And the robot should be in its original position after a lot of unnecessary spinning. And sure enough, false, and there's my robot. Let's try setting the robot up so that the left is dark, so I should get true. Here we go. Is the left dark? True. So my test works. And this is key because now I can define methods like left is dark, and left is dark sounds awfully useful for this problem I'm solving here. So in the next video, we'll put left is dark to good use. I'll see you there.